send out an email either end of this week, beginning of next week, where you can sign up for the third session. It'll be probably an hour time chunk over the course of a few weeks. We can only have 3 people actually soldering it all together at a time in the hackerspace with the actual PCB component. So whatever times work for you, we'll open it up. There'll be a whole whack of times, and we'll keep it open for weeks and weeks and weeks until every single person has made their PCB. So just keep your eyes out for that. That'll come, should be coming in by next Monday. We just need to get the parts in, make sure we have enough parts, and he's going to see how long it takes him. So we make sure that we give you enough time to get it all assembled. Is there any questions with that? Okay, beautiful, beautiful. And that's when we're going to check like attendance for it. Right now, it doesn't matter if there's, I don't know, like we figured that last time there was no real point in me going around trying to get as many people in attendance as possible. But when you guys come in to get your PCB, then you'll be checked off the list once you've received all the components and everything. Beautiful.
Are we good to go, Radu? Yeah. Okay. Well, I'm gonna start off with sourcing parts because I'm sure a lot of people here haven't come yet because we did kind of last minute change the time that we're starting today. Sticking to schedule though. I'm going to go over the sourcing parts, that part we had missed last time. So did I say anything? Yeah, that's for later on. Okay, so when we were looking at the file, we were going to go over footprints and all that and finding the parts. A lot of the parts that we have, if we need to find a resistor of any type, if you go to Digi Key, so digikey.ca, the Canadian site, you'll reach, yeah, so we'll have the main home page that they've got. If you search any type of part, like if we're looking for a resistor, you just type in resistor, and you'll be given a few options. So we've got chip resistors, we have through-hole resistors, which I'm sure a lot of people are familiar with. These are surface mount resistors. We've got resistor networks, which are single package, but they have multiple resistors in one package. Those are good for digital circuits and other stuff where you have parallel lines that need the same resistor. In this case, for our circuit that we're designing, we're going to be using chip resistors, so I'll just guide you guys through how we would look for the right type of resistor. Once you click on the chip resistor menu, you'll be given a whole lot of information here, a lot of filters. So you can narrow down from the nearly 1 million different types of products. You can filter through and find what you need. In this case, you can leave a lot of this blank, but if I remember correctly from the old circuit, we've got a whole lot of 470 ohm resistors. So let's try and find a 470 ohm resistor. We've got a ton of resistors here, so I'm just going to go 470 here and make that ohms. Let's see what shows up. It just dims it out. You got to scroll for a bit. There we go. Okay. So after a bit of scrolling, you can find 400, no, that's milli, never mind. Gotta go a bit more. The better the technology at making this stuff gets, the smaller the values you can get. There we go. Just here, 470. So we've got 470 selected. Just got to make sure I deselect. Yeah. So if we have 470 selected and that's all we're trying to find, we can just simply hit apply all. And it will narrow down just like that. From 1 million, we have 2,000 options. But 470 ohms isn't the only, oh, whoops, I accidentally selected 470 milliohms. Get rid of that there. And then should auto apply. Yeah, now we've got even fewer results. Now with the resistance, we'd also want to look at the power capacity. as well as the composition. Depending on the application, we'll want to have a different composition. That'll go into detail if you ever want to do a bit of research on that. That's a bit of a rabbit hole. Wattage, that depends on how much power you're running through it. If we're using LEDs, I'm going to be running about 20 to 15 milliamps through it. So at 3 volts, 20 milliamps, that's no more than like less than 250 milliwatts. So we can go with something small, quarter watt, 0.15 watts. If I quarter watt there, we can then find a quarter watt resistor. This all goes into just narrowing down the results. The package size. Now, package size is the most, when it comes to PCB design and surface mount, this is what you'll eventually just figure out after looking at different products, is all of the various types of packages. There are a lot. So in this case, with passive components like resistors, inductors, and capacitors, we've got basic packaging that we've got, the imperial and metric version. These are all the different types. We've got from 201 all the way to 1210 and further on. I always roll with 805. That's, I think that is the largest size that you can get for surface mount that makes it easy to solder by hand with. 603, you're getting into territory where you got to be a bit more fine on the motor control of your hands while soldering. 402, yeah, don't even try with a soldering iron, just put that in the oven. So yeah. Anyway, we're gonna roll with 805. I think that's what the footprint we're gonna look for is. And the rest of it, yeah, we can just ignore. You don't need to worry about temperature drift or anything like that because we're not doing anything too crazy. And when you hit apply, it should narrow it, yeah, right down to 61 results. So now you can just go through. I look at the stock because I'm not too worried about the brand, but if you care about the brand, the quality of the component, you'd pick based on that. Or price, the various little bits you'd want to care about. Also, you could check tolerances. The lower the tolerance, the more expensive it'll get. But just like that, we can choose this if we wanted to. It's a 1%. They've got a ton in stock, so we can order a lot, and it's only 15 cents. So stuff like that. That's how you would find a component, and same thing works for a transistor. If I wanted to find a transistor, I'd search up transistor. Bipolar junction transistor is probably what we're going to be using. I would just click on that. And after it loads, now we get a whole selection. Fewer transistors on their in their inventory, but good enough. Now here's another bit here is product status. Product status would be if they're actually manufacturing the component anymore or not. If it's obsolete, don't use it because you'll never be able to get it in the future. So there's that. Transistor though that goes into detail. You'd probably want to look at the data sheet of what you want to use and base it on that. In this case, we're going to be using a 3904. So I'm just going to search up the part number. And with the part number, you're able to then click on transistors. It'll give me kind of curated results based on that, as it's got a search entry there. And from that, we're able to choose a 3904. I believe this is the one right here that I selected. Okay, so now I'm going to show you when we get the part. If you click on that and go to the site that it has, we'll be given various bits of info. We have the part number. We get the data sheet, which takes you to the link of the data sheet, or it makes you download it in this case. That just gives you everything, all the details you need on this part. And to order it, I normally go through and source components, then add it to a list. And when I add it to a list, it allows me to select a list if it's existing, or I make a new list. And from the list, then you can order all the parts. You could share the list with a friend, share the list publicly, whatever you want. So yeah, that is sourcing parts. Now, I don't know how long that took, but I believe almost everyone should be in here by now, so we can start with the whole shebang. Okay, so I'll start off with the slideshow. Actually, I'll clarify too, one here at the point. Thank you for all those who gave feedback. That was great, especially the constructive feedback. I'm going to be going a lot faster in this session, if that little bit there wasn't already an example of that, since we have a lot to cover. Let's see what else. Yeah, if you have any questions for me, we'll be having a 5-minute break around 7:30 to 7:45. And I or TAs can help cover any questions or technical issues you have. And I'm also available after the workshop as well. I'm not constrained on time there. And if you feel I'm going too fast, do let me know, and I'll slow down just a little bit for a small portion of time to go over what I was talking about and pick up the pace again. So, yeah. I also have available some different versions, different zip files of the files that we're going to be working with at different stages along the tutorial. So if by the time we get to the break, you're still having troubles, say, importing components and footprints into the PCB, we can just send you the files over and you can essentially start from a different point. I actually have a guide this time to help me, so sorry about the unorganization last time. But yeah. Cool, so I'm going to start off with these slides. So the goal for tonight, we're going to be learning the basics of designing a PCB. This is the more artistic part of the workshop. So we're going to be setting up the PCB rules and configurations based on the manufacturer tolerances that some might have. Then we're going to design the board, including the board outline shape, the footprints that we're going to have the components on. We're going to do the traces, the silk screen, and the copper fills, so the whole copper area. And then we're going to use the design rule checker, so DRC, to check for the errors, any errors you might have. Just keep in mind the DRC isn't an be-all type thing. It is just suggesting and showing you where you have errors. You could easily send in a crappy file to the manufacturer and they will make it. So keep that in mind. And then we're also going to export the PCB to Gerber format. That is the manufacturer's format for fabrication. And then, yeah, I'll show you the process of ordering PCBs. I'm not actually going to order the PCBs, but I'll show you how to get there. So if that is all, I'm sure you guys have this file downloaded. It is the blinker session2.zip file. And if we extract it, let's hope this is the right one. Yes, okay, cool. So we have the project file in here. You'll be given all of these files. You'll notice a few newer files. We've got the library.pretty file. Library.pretty, this is a custom library with different footprints that I had made in my spare time for this project. I'm really creative with the name here, so I just named it library. You can name it anything when you're making the library. I wouldn't recommend renaming this, but yeah. And .pretty is just the appending suffix that KiCad uses for libraries. I also have the simulation file for the circuit if you guys wanted to play around with that further. I've got the E picture for the silk screen, but we won't really need to go into that. If you guys want to, we can open up the KiCad_project file to get to this menu, and we can open up the schematic editor. So last time I finished off without showing you guys how to work on the reference designators. So if in your old schematic you saw the R question mark, D question mark, battery question mark, Q question mark, all that, we need to fill all that in. So in either to do that, we will just go up here to this R question to R42 button, that little guy here. And when you click that, it'll open up this menu and it'll show you how to set the reference designators, so the numbers in those parts, and it'll give you a pattern. You can go from left, right, kind of down like a book, or you can go zigzag up and down the page. I go zigzag up and down the page because that is what I've always done. It's preference. Yeah, and we're going to do entire schematic here, so we can annotate it. And just like that, notice how all of the numbers are in the schematic. So we can close that. Everything's filled in. And on your old circuits as well, we'll hop into here. I pressed E to get into the properties menu. You notice how I've got a lot of other information here. This is just what I was talking about, how I add in custom stuff for record. You don't need to worry about that, but the data sheet and footprint is the most important thing. Notice how on these resistors, I have the A0805 footprint. That's what we had selected when we were filtering for components in the Digi Key filter menu. Here, this menu is it's got a lot of parts, a lot of different footprints, and this is where you have to search with the search bars up here. So in this case, if I was trying to find a resistor, assuming this is gone, right? So it's got no footprint whatsoever. I need to find a footprint. I'll hit these 3 lines. I'll go into the filter and I'll search up resistor. And it'll give me 2 options. I've got SMD and THT. SMD being surface mount, and then THT being through-hole technology.
How did you get into there?
There, I just did this. So I just went into the properties of the symbol.
How do you get into that?
You can right-click the component, or you can press E while highlighting the component.
Should we be following along right now, or
Yeah, you can just
and open up the PCB and go from the PCB design?
if you open up the schematic. Oh yeah, I should have clarified when to follow along. You don't need to follow along for the footprint here. I mean, you can check out the menu, and I actually recommend you check out the menu, but all the footprints should be there. So, but do the reference designators. Thanks for the clarification, Eric.
Sorry, so you're saying that we should put the R1, R2, R2, R3,
Yes.
etc.
Yeah, do the reference designators. So it's a quick and easy task. Just hit this button and annotate the circuit. Yeah, anyway, so you don't need to delete the footprint or anything. You can Control Z if you did. I'm sorry about that. But yeah, if you hit the 3 bars in this area here, it'll open up the menu for you. And from there, you can filter what part you're using. So in this case, we're using surface mount. Through-hole would be the larger components with the leads that you have to bend. And from the surface mount, you'd search up the footprint that you actually want to use. In this case, we're going to be using 0805. And just like that, we've narrowed down our search to 2 different components. We've got the hand solder and just the regular. The difference between the regular one and the hand solder one is pad size. It makes it easier to solder with an iron instead of just using a hot plate. So I recommend all of the, if you're doing a project, I'd just use the hand solder footprints. It makes it a lot easier. So just like that, and that sets it right there. So yeah, and then same thing goes with the footprints on the transistor. There's different various footprints that you can choose. Same with capacitors, diodes, everything else. And if you're ever confused on which footprint a transistor has, the data sheet will tell you. And then you just punch the part footprint into KiCad and it'll find it for you. You will have to do a bit of searching, I'm sure, but it should be easy enough. Now, with that, our schematic should be done. It should be filled in. All of the pertinent information is there. And if we're at this point, we can then hit this button up here. This will take you to the PCB editor. And when you hit that, we will see it open up. Hopefully this laptop doesn't die on me. Hey, there we go. Okay, and you can close the schematic if you want. And just like that, we have our PCB editor. Okay, so let's see, I'm going to cover all of the all of the menu options. There's a lot more here than there were on the schematic editor to cover, and I will zip through some of them that aren't as important, but some of the ones that are, I will clarify on. So we'll start off with this side menu here. We've got the grid dots like usual. We can switch with this button here. We could switch between degree radius, so polar coordinates and Cartesian coordinates. That is good for some use cases where you have circular PCBs or just prefer that coordinate system. Once again, you can switch between units. I just choose millimeters. And same menu here. We've got the full screen crosshairs. I suggest you actually enable those. This is a lot more useful in this menu than it was even in the last. Okay, so we have Rat's Nest. I will get into Rat's Nest when we import the components because that will indicate all of the possible connections you can make. This guy here, I'll talk about when we import stuff as well as the rest here because it is hard to describe it when you don't have parts. If we go up to this button here, just right of the save button and enter it, that'll open up the PCB configuration menu. There we go. Okay. And we'll get this menu. So this guy here allows you to set all of the layers, all of the trace constraints, and everything else for the board. Yeah.
When I click on that, it says project is missing, but we don't. Some settings may not be edited.
Oh. Did you opened up the KiCad project file, right? Is anyone else having that issue where they can't, is it a read-only file or? Anyway, if everyone's still good with that, I'll continue on. Anyway, in this menu, we've got these menus here we don't really need to worry about. This is for PCBs where you'd have more than 2 layers and a few other fancy things. Given that this is a stack up, being the actual how the PCB is made. We'll skip over that. That is a bit more of an advanced feature there. Same with text and graphics. But what we really care about is the design rules. So the design rules here, this guy here, is how you configure like the minimum tolerances that the software will allow you to make your PCB to. And I think I have a description of each here. Yeah, okay. So on this slide here, I have that menu, and I'm kind of describing all of the different settings here. So minimum clearance, that's the minimum distance between traces. Track width is the same thing, the minimum thickness of a track. Minimum annular width, that is for vias, which we will be using to kind of have a wire between both layers of a PCB. And then same for minimum via diameter, that's just the minimum size a via can be. Copper to hole clearance, that is the distance between a trace and a drilled hole. And vice versa for the copper to edge clearance, that is the distance copper can be from the edge cut of the board. For holes, that's pretty self-explanatory. Hole clearance is the difference between 2 drilled holes, and minimum through hole is the minimum diameter that the manufacturer can actually drill. Of course, we're going to be using PCBWay, in no way affiliated, but they have on their site, and every other manufacturer will have what their tolerances are. And I suggest whenever you're making a PCB and you plan on ordering from a certain fabricator, you look at what they are able to make and what they are capable of. Sometimes they have finer tolerances, but at a price, so also keep that in mind. I take it that is the last slide, so we'll hop on back here. I configured this already for you guys, so should be good there. Now, going on along here, the menu items here are pretty self-explanatory. We've got, you can refresh your layout, you can zoom in, zoom out, all that. Yeah, and then of course you can flip between the PCB and the schematic. The buttons are in the same spot. On the right side here, we've got all of our tools. So you've got your select tool, you've got the toggle for rat's nest on selected items or just all of them. I keep that off. We've got this menu here is to add a footprint, so we will be using this menu quite a bit. And then this tool here is going to be used the most. That is how we actually route traces. Here, this is for tuned length traces, because sometimes you have to worry about propagation error and propagation delay on signals. So this makes consistent lengths of copper, in which you can actually specify the length you want the trace to be, and it will make it that length. We can add a freestanding via, so that is how we're going to make signals and route them between the two layers. We've got a filled zone. A filled zone we will add at the very end. That will be how we create a ground plane or a power plane or whatever other plane we want. And rule area keep out, that is just for design if you ever want to have an area where you don't want copper or you don't want traces or components to be. That's how you do it. That's the tool you use. You can draw lines, you can draw arcs, you can draw squares, circles, and whatever else you want with these tools. This was used to create the edge cuts as well as some of the silk screen designs that we are going to go into. I did already provide you guys the edge cut so you don't have to design it, because we are trying to shape it like an ohm symbol. That took me a long time to do, so I just provided the complete footprint here. I will though release a video explaining kind of how to use these tools. Especially the arc tool. That one can get a bit tricky with measurements. Okay, so I think that's all of the tools. You can also, that's pretty much it. Cool. Okay, so this appearance menu here, just along the side, this is going to be used quite a lot as well. This is how we switch between different layers and different types of, just different layers. Because we've got the silk screen layer, so that is the ink that we've got on the PCB to tell you where the components are going to go and the type of components. So if you ever looked at a PCB and you see like C1 or D1 or Q5, 50, 100, there's plenty of components. That would be the silk screen telling you that. And then we've got the front and back copper layers. And you also have fabrication layers, courtyards. I'll explain courtyards when we import stuff. We've got edge cuts being what creates the outline of the PCB. And you don't need to worry about user drawings or comments at all. With that said, now we can go into the title block here. It's the same as the title block in the schematic. Just go in, you can edit, add the revision, title, whatever you want. And you can hit OK, and it updates it. OK. So we've got all that. I should actually go into the configuration menu again. I had forgotten to mention trace and via standard widths, predefined sizes. This is, you don't have to do this, but it saves you a ton of time when you're designing a PCB, is to set standard widths so that you're not having to go in with every trace and edit the thickness.
How do you get to that?
Just this button up here. And then you go along the side menu and predefine sizes. Yep. Anyway, with predefined sizes, you just add one, and you don't have to add one, but I'm just going to show you as an example here. I can add an 8mm wide trace. That is a very thick trace. But just like that, by doing that, I now have that standard trace width, which I can select whenever I lay a trace. Vias are essentially just little drilled holes with a metal sleeve put into them to transfer electricity from the top layer to the bottom layer, because two layers are insulated from each other unless you put a via through it. This is just a standard size for a via that the manufacturer can make. So we're going to roll with that. And yeah, differential pairs, we don't need to go into that, but that would be for transmission of data and other stuff where we have to worry about capacitance and inductance. So, bit complicated, don't need to worry. With that said, now we can import all the components from the schematic. So this is why, I should actually clarify, this is why we open up this file first. We wouldn't be able to import the components from the schematic into the PCB editor unless we had opened our project from this file first. I don't know why KiCad does that. It's whatever. But if we click on that, it did a thing. Ah, there we go. If we click on it, it should go through the schematic file and grab all of the footprints we assigned the components. And when it does that, you can double check it if you want. It didn't give me any errors or warnings. So that means we are all good to go. And when you hit Update PCB, it will give you the handful of components that we have for our circuit. It doesn't order them really at all. It just bunches them together. So when you place it, we'll actually have to sort through them. But in the meantime, let me know if everyone is good with that. Yeah.
I got lost. How did you get that?
Okay, so I imported all the components. Here, I'll actually delete these. So you're wondering how the components all got imported?
So
Okay.
I'm opening like the
I don't
keypad
think we need to say it
from where
Yeah, so if what I was clarifying there was you'd want to have this KiCad file, you'd want to open up the project from this file first before doing anything. So as long as you did this, you don't need to worry about anything. I was just saying if you are to open up the schematic file just by double clicking this, you wouldn't be able to, actually I could probably show you. You wouldn't be able to transfer all of the stuff here. As you can see, oh, it says that, but you can see up here in the menu where that one icon would be where you can import from schematic. It's not there. So that's why we'd want to open up this project file first and then open up the PCB. So as long as you can see this button up here, you're all good. You don't have to worry about that. Of course, you could set the grid size. I should mention that with the top bar. This is how you set the grid size. You can check. This is how you select your standard widths. So if I was to place a via, I would select that. And if I wanted to place a trace of 0.35 millimeters, I would select that. Or if I want to lay down a trace of 0.5 millimeters, I would select that. Now let's import the components again. I just select this button right up here. It should be 2 buttons left of the layer selection here. And when you click on it, it should, slower laptops like mine, it lagged out a bit, but after a while it should give you this pop-up saying all the components have been imported. If there is an error, it will say, and if there's a warning, it will say. So yeah, and when you hit Update PCB, it should just pop them all in. Yeah.
Yeah, I've brain free
Hmm?
I've brain free
Okay, you have 3 errors. Okay. And this is why I made a second file. I don't know why this is so late. Okay, there we go. So I made a second file for those of you who are having issues importing importing the stuff. If you go to the Discord, we've got the blinker _session2_pop. The pop meaning populated. I've already populated the PCB file with the footprints. It should be good in terms of the error for you. Put your hand up if you're still having an error. Anyway, going back to this. Now that we've got our components put in there, let's find our edge cut. So let's get the layout, the outline of the PCB, because we need to find out how we're going to lay these parts out inside the PCB. If you go up here to this footprint symbol where it says add a footprint, alternatively you could just press A. That is the shortcut for it. When you hit it, it will load all of the footprints. This thing's a bit slow. There we go. Took me to the same spot. I just gotta let it wait. I even went to Best Buy to get an adapter, so I'm not screen sharing. Save up a bit of the RAM.
Where did you get the picture from? Is that on the file?
Which?
The picture or the, I don't know.
These guys here? Yeah, the footprints. Yeah, I just went to this button up here, and when I hit it, it will bring them in. And if you hit Update PCB and then close it, you'll be given all of the.
Clicking that thing up in the top.
Yeah, just after clicking this, it'll give you all of these parts. Oh, look at that, it opened. Okay. So to get the board outline, the edge cut, I'm gonna search up my very creative library name, library. And it should give me my custom library here. And in my library, I've got the hole for the pin, because this is a badge, so you can hook it up to your clothing. This is the battery footprint that we have already imported. You've got the edge cut, and then we also have the silk screen design that we're going to have on top. So we're going to import this edge cut by double clicking, and you can place it anywhere. I suggest you use a coarser grid size, and this will come into play later. So I'm just going to place that down. Yeah.
How did you get to choose footprint?
Just this button over here. Or alternatively, you could press A, and that would work too. And you can move this around. The reason I suggest the snappier grid is so that we can place the button here, or the battery in the middle of it relatively easily. But first, with the edge cut, just so that we don't move it around while we're working on the PCB, I'm going to edit the properties. So you can right click and press properties, or you can just click on it and press E, and you'll be given this menu. You've got a lot of options here. You could select where the position is on the schematic itself, or edit the footprint or whatever else you want to do. But in this case, we're just going to look at move in place, and we're going to lock the footprint. And what that does is now it'll notify me whenever I'm trying to move it. Like, I cannot move this anymore, which is good, because sometimes when you're moving around components on the PCB, you'll accidentally select the whole thing and move it, and then all of a sudden it's a mess. So that just saves you that hassle. And how I did that, just again, I went to properties while selecting this edge outcut, hit properties, and I went to move in place and made sure it says lock footprint.
So in the choose footprint, where did you get the
I just searched up in the filter here, just search up library, and oh whoops, I didn't want to add that, and it should be down there under ohm edge cut 45 by 45 millimeters. Okay, so now that we've got the edge cut here, it doesn't matter where on the schematic it is. You can easily move it around after the fact by highlighting everything. But in this case, I have it here. Wherever you have it works for you. Now let's move the battery here, and we're gonna flip that to the back side. How I did that, notice how it went blue? That means it is now on the back of the PCB. So blue means the back layer, red means the front layer. So whatever we have facing outwards is gonna be the front layer, and whatever's behind is the back layer. In this case, we don't want the battery to be showing on a badge, so we're going to put it on the back. And likewise, we'll be doing the same thing with every component except the diodes, but I'll get to that in a sec. And I'm going to place this just in the center of the outline here. And I like to rotate it so that it is facing like this. You can move around the silk screen part number wherever you want. I would put it in a nice clear area, easy to see. You can choose your grid size to move it even finer, and just like that, we have that placed. So here we go. Yes. Okay, so now we're going to sort the components. Sorting it is pretty much half the work right there. Yeah.
Sorry, I just missed how you flipped the battery.
You can flip it by right-clicking on it and hitting change side. So that is how we flip it from the back side to the front side. You can rotate with R or Shift R to go counterclockwise. Alternatively, you could also hit these buttons up here. That works too. And that'll give you this. Now, yeah. Anyway, one transformation you do not see in a PCB editor is a mirror. That's simply so that no one accidentally mirrors an 8-pin IC footprint and then messes up the footprint entirely. But you don't need to worry about that since it doesn't even allow you to do that. Okay, so I'm going to sort through these components now that we've got the battery down there. How we're going to sort through these components is based on our schematic. So you could look at the schematic and figure out how you want to lay out the LEDs. I should have had that drawn out actually, my bad. But if I open up the schematic here, oh, it's already open, cool. So I'm going to kind of lay this out so that the LEDs alternate, just going around so that they're not all over the place. So I'm going to make every one of these LEDs I'm going to make all of these LEDs I've highlighted on one side of the board and then all of the other ones on the other side. Oh, I opened up the schematic. You could easily hit this button here. Yeah. Anyway, this comes down to how you want to lay out the PCB. You can do whatever you want. This is creative freedom. So I'm going to follow this layout. So I'm going to have R1, R3, R7, and R9 on the left side of my edge cut. So I'll have R1, R3, R7, and R9 on this side, and R2, R4, R6, and R8 on this side. And to begin, I'm just going to move all of the stuff we want on the back of the PCB. So all the stuff we want on the blue layer, I'm going to move them away from the diodes. Kind of organize all the diodes, separate them from the resistors and every other component. That way I can flip everything else. You can select multiple things if you hold Shift and click on the things. And if you click on something like a resistor and you don't want that in the group, if you hit Shift and Control, it will then unselect it. You can see the change in symbol when you do that. As you can see, just below my cursor is the minus symbol. If I let go of Control, it becomes a plus. If I let go of Shift, it returns to normal. Shift, Control, Shift, Control. That's how you do it. Now that I've selected all the diodes, I'm going to move them out of the way and just tuck them away over here, because these will be on the front of the PCB. Now all of these capacitors, resistors, transistors, they are going to be on the back side of the PCB, so I'm going to want to have them in a group, highlight them all, and hit F, or right-click anywhere while on the highlighted component and hit change side flip. That will flip it between the back and the front. Yeah. Anyway.
Can you repeat how you did that last time?
The flipping?
With the
Selecting?
after you did the diode.
Oh yeah. I just organized all of the parts here, grouped them together, and I highlighted all of them just by dragging and dropping. Right-click on them. You can right-click and do flip, or you can hit F to flip them as well. That is the shortcut for it. Okay, so now let's organize components. Actually, I wonder if I can just do this. Pop that on over there. Exit out of this. With that, I should be able to, yep, okay. I will flip between the PCB schematic, or the PCB and the schematic. So I'll kind of lay it out the same way I've laid out the schematic, where I've got Q1 on the left, Q2 on the right, C1, C2. I'll just do that, and then we can work from there. It's good to not do everything in a small group, but kind of organize it and then make it more compact as you go. So let me grab Q1. I'm just going to throw that guy there. You don't have to worry about being too intricate. C1 can go with Q1. C2 can go with Q2. Now I'm going to lay this out the same way I laid it out for another, for the original that I had made. The one that we are going to be learning how to solder on. So if I see here, yeah, okay. So I do have it right. Awesome. Anyway, Q1, Q2, C1, C2. Now, like I said, I'm going to have it alternate. You can do whatever you want in this case, but I will kind of organize these resistors based on how I want the LEDs laid out. So like I said, I'm going to want R1, R3, R5, and R7 on this side to go with diode 1, 2, or diode 1, 3, 5, and 7 as well. But keep in mind the reference designators change because R5 and R6 are here, so R7 and R5 will be grouped together, R8, D6, R9, D7, D8, so on. So let's look. We want R1, R3, R7, and R9. So I'm just gonna grab those here. So let's see, R1, R3, R7, and R9. I'm just gonna drag them. Now, while you're dragging items like this, you can hold right-click to kind of pan to the side. And a nice thing about KiCad that I always love talking about is the fact that you can just slide infinitely to one side and it'll snap to the, it'll wrap itself around basically. Anyway, I'm going to just place these resistors on this side of the PCB. No, not really care about where they're placed, but just have them there so that I can work with them. And with that, I should also add R5 next to Q1 so that we have that there as well. So I'm just going to grab R5 and place it near Q1 as well. Okay. So now I've got that one side. We can easily just throw everything else that we have on the other side. We're going to want all of these. I'm going to put R6 near Q2, and then the rest of these can go on this side. So we have 2, 4, 8, and 10, just like that. And just like that, we already have like majority of the components on the PCB. And while I let you guys do that, I'm going to show you a cool little menu that you can just check your work on. You don't have to follow along, but if you hit Alt-3, you can see your PCB in 3D. And just like that, I wouldn't say that this is the greatest PCB layout, but you would be able to see what the manufacturer would actually make, supposedly. Alternatively, you could also go into one of these, go to View and hit 3D Viewer. That's also how you can access this 3D View menu. And yeah, just like that. You can see it in 3D. You can even render it if your laptop is powerful enough. Mine is not. Okay, so now that we've laid out all the components on the back of the PCB, we won't get into the diodes just yet, but I am going to start to lay out the resistors how I want them based on the LEDs. So I'm going to just organize them based on value. R1, R3, R7, and R9, R2, R4, R8, and R10. R6 and R5 are with Q1 and Q2, and I'm going to start down here. This is entirely whatever you want to do. This is the creative part that I was talking about. It's however you want to lay out this PCB. And yeah, I'm just going to whip through this, and you guys can catch up at any point. And while you guys are catching up, I will explain good practice for trace layout, because that would be important. So I'm just going to throw a C2 right there. And if you need a component to work, okay, actually I should explain what the rat's nest is now that I thought about it. So, like I was saying in the side menu, you can see all the components. The rat's nest here are all of these lines. These lines that are going across, these indicate which connections you can actually make with traces. So, as you can see here, this line going from ground all the way to this pin on the transistor, if I was to try and make a trace from it, you could see how it only highlights those two pads, because those two pads are the only pads that ground can connect to. That's what this white line basically indicates. It shows that node on the circuit that connects to. You can turn the rat's nest off if you don't like looking at it. I have it on because it helps me design and lay out stuff, especially with this capacitor, because you could see when I had placed it, you could see these rat's nest lines are kind of crisscrossing. I flip it around so that I don't have that crisscross issue, because now I can just connect these two just like that, that type of deal. We're not going to place traces just yet. You can organize, lay out the stuff. You can place traces as you lay components out. However, if you do go down that road, you'll be deleting a lot of traces and replacing them as you make changes. So as long as you're good with that, you do whatever you want. Okay, let's see. So this resistor here, and yeah, as I plan out how I lay out the PCB, I just look at these lines. Like, I have this component selected, and you can see the two lines that are coming from it. I keep in mind where that line is, and I think to myself, will I be able to put a trace between there? In this case, I won't be able to, because this line is connected there, and I won't be able to put this trace there unless I go around. But as you can see, it was glitching out like crazy there. So just plan it based on that. Yeah, go for it.
How did you, so the C2, how did you get that?
You can right-click it. You can right-click it and rotate it with these two, or you could just hit R. R is the shortcut for rotating. As long as it's highlighted, you can rotate it. And of course, don't be afraid to move around the reference designator silkscreen. Get it into a spot that looks nice. Because you don't want none of this. This is not acceptable. You won't be able to read which part it is when you get the board in from the manufacturer. So keep that in mind. Now, you don't have to worry about, with a 2-layer PCB, you don't have to worry too much about components getting, like traces getting trapped and having to reroute traces, because we have a magical tool called vias, and they allow you to essentially route traces on the other side of the board. And I'll get into that in just a second, but here I'm just going to lay out the way I kind of had it set up in with the PCB that I'm going to be ordering for you guys. And if you're like me and you really like symmetry, this is why I like the full screen crosshairs, is because now I'm able to line that component right up with this component, same y-axis. Snap to grid, you could change the grid size. If it doesn't seem like it's snapping, that's probably because you have a really fine grid. You can change the grid to be even 6 millimeters. I would never do that, but if I set it to 1.27, now I'm able to snap it to a 1.27 millimeter grid. That is half an inch, I believe. Yeah, no, yeah, half. Or 1/50th of an inch. Yeah. I usually, by default, I use either the 0.240 millimeter snap grid or the 0.127 snap grid. But it comes down to preference and measurements. Okay, so I'm gonna quickly not edit the board. You guys can continue editing, but I will go over good practice, because that is pretty important as well. So,
Can you take a 5-minute break here pretty quick?
actually, yeah.
Is right now the time, or should I go off to
No, I think it would be a good idea, because I should place traces, and then I can go over all of the practice, the methods that we'd use. So, I think it would be a good idea to have a break here, and then people can work on the. You guys can work on placing around components, or go grab water if you need, so on and so forth. So, 5 to 7 minute break here, and we should be good. Okay, so I'm going to start back up here. I was just answering a few questions that you guys had while I was walking around there, and I should clarify one or two things. So make sure all of your components are blue inside of here, so make sure they're on the back side, of course. And then some of you might be wondering why these things look like they're, look like you're looking at them through a mirror. You don't have to worry about flipping those or flipping them on the axis so that they're readable. This just means that they're on the back side. So you could imagine it as if you're looking through a piece of glass with the components on the back side. When you flip it around, actually, which I will just show you in the 3D menu. This would be the front, and if you flip it around on the back, it will be readable in the right direction when the manufacturer makes it. So you don't need to stress out about that. Yeah, anyway, if you guys haven't already, you can lock the outline by going to Properties and hitting Lock Footprint. I think there is another menu here where you can lock it here. I can't remember if that actually works or not. I just go into the Properties. And then, yeah, you can set the battery into the center if you want. Do whatever you want. Anyway, placing components down. If you guys are still working on that, I will continue to just rush through there and place them the way I've had them. And you guys can kind of just copy it if you need, or place them however you want. It is your project. And once again, if you're placing components close to each other, kind of like this, don't have the blue outline known as the margin, or the courtyard, I should actually say. That is the courtyard. Make sure the courtyards don't overlap, and I would actually give the courtyards just a little bit of distance. I will get into the reason why we leave distance between components, but yeah, just make sure you have a fair amount of distance. Doesn't need to be much, but we have a lot of free real estate here, so you can do whatever you want. Yeah, that is that. And you can move the reference designator into a clear area so it is still readable. And while you're placing components down, do keep in mind, just keep track of where the rat's nest lines are, so that you can place traces. Once you start placing traces, you'll kind of find out what happens if your rat's nest lines are just a little mixed up. So far, I've got all of the components placed down, kind of like this. You can see the space I leave here on the side. That is mainly because we are going to be sliding in a CR2302 battery on the sides here, so I keep this side clear of components. That way when we're putting the battery in, we don't just completely rip a component right off the board. Yes. So while you guys place down some more components, I will go over good practice for traces and layout. So good practice, don't rely on auto routing. So software like KiCad, Altium, all the other PCB softwares, they will have a small program in them that will automatically route traces and place components so that it works. The issue with that is it can sometimes make some illegal moves. It won't always design it the way you want the board to be designed, and it does not have your brain, so it won't actually know what the board is going to be like. It just does its job as an algorithm. It will take longer to design it by hand, especially for larger PCBs, and auto routing can be useful for small designs or stuff where you really don't care to waste time on it. But in general, if you actually, if you care about how it'll turn out and the functionality of it, just consider auto routing as a newbie type of move. You'll never see this on PCBs as well. If you ever see kind of like the pictures of circuit boards or whatever, you'll never see a 90-degree track. So you can see here how it by default, it wants to create 45 degrees. It'll never do a straight L shape. The reason for that is this here you never want to do. The reason for that is when they make the PCB, what they do is they actually etch the copper away with an acid. And when the acid eats that away, it'll get into this little crevice here, and it'll kind of eat away a little pocket in there. And that little pocket will then thin out this trace, and if you have signal properties that the trace depends on, or if you have a certain amount of current, max current, whatever, going through there, it'll affect that, as it's kind of a weak link, a small portion that will be affected. And not to mention, it kind of doesn't look as good as 45 degrees. So that would be a no-go move. Try and not do that. Okay, another note to keep in mind is keep traces kind of direct. Don't have them loop all over the place. Keep them nice, tidy, as short as possible, just to keep down any resistance and whatnot. Oh yeah, this is a big one. So do not route traces underneath components if possible. In some cases, you can do that. I know I've made this move too. It's not as uncommon in the industry, but for signal dependent stuff where you have say you have a low voltage signal or a really high frequency signal, and you route it underneath of another trace. So say I've got this, I route it, say I route it through there and go all the way here. Okay, so I'm routing it under this component here. What that does is, say this transistor was switching at like 200, 300, 1 gigahertz, 300 megahertz, whatever. If it's switching at a really high speed, it will induce or capacitively couple to the track underneath of it, and it will introduce a little bit of noise into that. And what will happen is now whatever I have connected to this trace, it will pick that up. Sometimes you don't need to worry about that, especially in this case, we're not using high frequency stuff or anything along those lines. So honestly, you could go under a component, but it is good practice to not, and if at all avoidable, or if possible, I would avoid it. So there's that. Moving on. Yes, keep noisy or high frequency traces from being parallel to each other. So if I had two really long traces going from, if I had two traces kind of like this, and then this one splits off, if these two are really noisy, say this one's a noisy power line, or it's a signal that could capacitively or inductively couple with the other trace, it could induce kind of a reflection of that signal on this trace, and if you had any other sensitive electronics connected to that, it will pick that up. And so you want to try for long, specifically for long traces, you want to try and keep them from being too close. Once again, you can get away with quite a lot. It depends on the design. Always keep in mind your design. And yeah, you want to place your components based on what they are. So if I had, say, a CPU connected over here and I had electrolytic capacitors for the power supply, I wouldn't want to put those near a heat source because some components can't handle the heat. Especially capacitors, which can change their value based on heat, temperature, and inductors, and everything changes their value based on heat, temperature. So that's something to take into consideration as your design. So always do that. What else? Yes, make sure reference designators are clear and readable. You don't want them overlapping, or in a lot of cases, some people might have them in confusing spots where maybe two resistors are kind of alongside each other and you've got a reference designator sandwiched between two components. Sometimes you don't know which one it belongs to. You want to avoid that. So make sure it is as clear as day that, say, this resistor is R8 or vice versa. And what else? I think that's it for good practice. Oh, actually, you'd want to make your power and ground traces thicker. Specifically power, I don't always make my ground traces thicker, although I should. The reason you want to make power and ground traces thicker is because they're carrying the brunt of all of the energy that you're consuming from your circuit. So to have them a bit thicker would be important, especially depending on how much current you are drawing. And vias are also good for thermally dissipating temperature, not just connecting a trace from one side of the board to the other. Specifically because if you put multiple vias around a component, you can kind of have them channel the heat, the temperature throughout the entire board. Yeah.
So for like the width of the track with respect to current, is there a menu to what dimension?
Yeah, so there are formulas online. KiCad has a nice calculator that you can use for that. If we actually go to this blue menu, you don't have to follow along, but you can if you want. If you go to calculator tools here, it gives you a whole heap of stuff. So the first option, regulators, you could do RF attenuators, E-series, which is standard values. This is good for making modifications. You've got a color code, transmission line stuff. We're going to care about via size and track width. These two here allow you to kind of set based on the amount of current you plan on running through your traces and vias. You can figure out how large of a via you want. I go overkill sometimes and I just make it like double the size I need, because then I don't even have to worry about how much current I'm running through it. But for more compact builds, compact designs where you're trying to get this stuff as small as possible and you want to just push it right to the limit, this is the tool to use. Of course, these are based on just formulas, ideal situations, so I would always give it a bit of a buffer, a little bit of extra so that you don't chance anything. And same with track width, you can set the current that you're going to run through it, the temperature difference that you want it to reach but not go over, and then the length of the wire itself, the trace itself. So these are good. Yeah. So that is located at Calculator Tools. It's a very handy tool. And yeah. Now that you'd use that initially to set the trace values in the configuration. I have, for you guys, I've set the trace values to be 0.35 or 5 millimeter. I'm sure you can all guess why I have the 0.5 millimeter. That is for the power. And the 0.35 millimeter is for everything else. So since I already have the backside kind of completed here, I will start laying down traces and show you guys what the plan is with that. I'll start off with the obvious stuff first. I'm going to do the power traces. So how I'm going to do that is I go up to this drop down and I select the track 0.5 millimeter trace. And then I can go over here to this button here to route tracks. And if I click that, it will snap to paths. So you'll know if that's selected, if it snaps to paths. And when it snaps to paths, you can hit that and it'll highlight all of the paths that it wants to connect to. You'll know which paths it connects to based on the rat's nest as well. And if you're getting annoyed with the rat's nest, you could turn it off and it will still highlight the correct pads if you want a clean display. If you're annoyed with the straight line rat's nest, you could actually make them all curvy. If you want. I mean, it kind of gets them out of the way, but I do lines. Yeah, anyway, I'll lay down the first traces here. Yeah, and kind of just go along. You'll notice sometimes the traces will enter into it at a weird angle. It doesn't matter too much. If you care about the aesthetic of your board, you can kind of make it go into a shape like that by selecting there and then continuing along. By left clicking as you place a trace, you kind of create a new node to go off of, and then you can do whatever you want, just like that. And I'm just going to go along and connect all of the pads to this here so that I can kind of move along just like that. And I'm going to continue on up here because I have these pads that need connecting to, just like this. Okay. And with that, the power traces should be done. That is pretty much all the power is connected to are those initial resistors. Let's see, okay. So I should also note, try and keep your components distance away from the edge of the board, because you don't want to be soldering a component right on the edge. Actually, most manufacturers won't even allow you to do that, so keep that in mind. Also, notice how I flip that because I saw this rat's nest is kind of crisscrossing. I do that so that they create nice, clean traces. This guy here, I can then continue on, snap those together, kind of go around, connect to the easy traces and figure out the rest. You can delete traces if they're not working for you, and so on. Just like that. I'm going to leave the ground traces as kind of a last thing to do. The reason being, we can create a ground plane, so we can create a whole copper, like the rest of the copper around the PCB could be turned into the ground plane, so that we could just connect everything everywhere to that. So yeah, we don't need to worry about that just yet. Yeah, go around. And you'll know you're making progress when the rat's nest is kind of disappearing a bit. I should also note some of these are connected to the capacitors or the LEDs, so we'll focus on that after. But yeah, I need to move this resistor over here though, because I just realized they're in the wrong spot. And see, just like this, I noticed an issue with my placement, so I'm just going to go along, delete these traces, and place them back with my new change. You just select traces. Now, if you have traces that are overlapping, you can actually switch between all of them in this menu. In this case, it also highlights it, so I'm just going to click on that one because that's that, and I'll just do this. And place that guy down, place this guy down, just like that, and make sure I'm at, ooh, I'm using 5mm traces for all of these. I've already made a big mistake. I should have mentioned, as you're placing traces, when you do the signal traces, you have to select the new trace size to change the sizes here. So I'm going to continue with the 5.5mm one, simply because I'm placing power traces. But when I move to signal traces, kind of like I am now, I'm going to select 0.35, and then I'll go around and start making traces. They're not much thinner when you look at them, but they allow you to kind of route them a bit more freely. This guy is still 0.5 too. I need to do that. There we go. This guy can go there. And if you want to adjust a track after the fact, you can also select a portion of it and kind of move it around. As you move it around, it will adapt to whatever you're doing. So there is that as well. Let's see, what else? This guy can go, yeah, that goes to the diodes. Great, so we've got that. And as you can see here, that created a 90 degree. So I'm just going to go in here, kind of adjust that based on what I'm doing. Move it around, make it look nice, that type of thing. Okay. Anyway, moving along, I'm going to connect this guy here. Yeah.
So were you just adjusting the 90-degree angle that you had before?
Yeah.
So when I'm adding one on the 2 from Q2 and bring it up top, it's not letting me place one up top.
Oh, so if you're, sometimes you got to fiddle with it. If I delete this trace here, and I bring this trace up here, if it's not allowing you to, sometimes you will have to kind of place a new point in which you can run off of, and then it'll allow you to route it around. To delete, you just highlight it, and then hit the delete button, or you can highlight it, right click it, and hit the delete here, and it'll work just like that. Yeah, and sometimes how the kind of algorithm or whatever it uses to lay out the traces, it will glitch out sometimes, and it will be a bit frustrating at times. I know I've had my fair share of annoyances with it, but what you could do is you could easily just move around the part a little bit to get it to work, or you can change which pad you're running off of, and it'll usually it'll work itself out eventually. Now, as you can see here, I'm already running a trace underneath a component. Sometimes that can't be helped, and in our case, it doesn't matter, so this is all right to do. Yeah, that should be, I think that's all there is for this, this bottom part here. Now, some of these rat's nest are going to the LEDs. I'll just sort these out actually while I'm at it, because we should get them ready for the rest of the thing here. If we have, which one was it? We have diode 1, 3, 5, and 7. So I'm going to take diode 1, 3, 5, and 7. Drag those over there. Okay. That kind of made it a bit nicer on the eyes in terms of rat's nest. Cool. So now that I've got those traces kind of down, we don't have the ground traces laid out, and we don't have the LED traces laid out. So that we'll get into, but first I'm going to show you how to put in the silk screen, since we're going to want to lay out the LEDs based on the silk screen so that it looks nice. So if you want to follow along, we're going to go to the footprint menu. So you could hit A, or you could go to the side menu here where that symbol is. And we can adjust the footprint, or grab a footprint. So if we go to the filter, search up library, which is the custom library. If we go down to UBC E-ohm silk screen here, double click it, we get it. And I'm going to try and find it, find the center here and snap it to it. Or you could just kind of eyeball it. It really doesn't matter actually. I think I got it first shot there. So center it around there and you're good. And there we go, we've got the E in. Now of course you're going to be confused at why I'm looking at the yellow and the blue mixed together. It is a bit of an eyesore. So to get rid of that, I'm just going to click this button here. So what that does is it highlights the main layer that you're working on and makes everything else in the background kind of dimmer, just like you can see layer 1, or the front copper layer diodes here are going to be dimmed, so is the silk screen, and everything I select is going to be blue. And then all I have to do to switch which layer I'm working with is I will go up to this and say I want to work with the front copper stuff. I select this, or if I want to work with the silk screen, I can go here. And same with the back silk screen, but don't need to worry too much about that. So I'm going to lay out the LEDs in whichever fashion I want. I'm going to lay it out inside this ohm rim here, just so that they are placed nicely. Doesn't matter too much as long as they are where you want them to be. And they can be anywhere. Like they can be over top of these components here because it is on the front side. Yep.
When did you get the silk screen for the?
I went to the same way you got the edge cut. I just went here to the footprint menu. I pulled that up just by pressing this, or you could hit A. And then I just selected the silk screen. Anyway, yeah, we placed the silk screen in the center. And I'm just gonna, I'm gonna lay out these LEDs. I don't need to lay it out in any particular way. As long as you are happy with it, it's all good. I'm just gonna throw them on because of time. So, the way I have them laid out as well is I've got them going from 1, 3, 5, 7, and then whatever this one is, 2, 4, 6, and then 8 going along here. And when we go, when you look at this, you can see how the silk screen is kind of clipping with the layer here, the thicker lines. You can fix that by selecting the silk screen layer so that now you're focused on the silk screen layer, and you can kind of go in, select that, move it out of the way, make sure it's near the diode so that you can see it. Do that. Do this, kind of make it so that it's readable. You can put it on either side, it doesn't matter. Diode A, and I'll just put that there. 7, put that there. Just make sure that you can read which diode it is. Now in this case, what we've got here is this little outline, the square box outline on the diode component footprint here. You can see, if I move this out of the way, you can see how it's got that box going around the one side. That's meant to indicate which direction the diode is going, since a diode is a directional component. In this case, I'm having them all go in one direction so that when we solder them together, we know which one it is, especially since that box is going to be covered up by this edge here. That is sort of unavoidable. I didn't make this thick. I didn't make this wide enough for these components to have the silk screen fit in. But if you know how it's designed, then you can get away with stuff like that, as much as it is not really recommended. So I'm just going to place that the way I had it before, sort of adjust that. Anyway, so there we go. Now that we've got the components haphazardly placed, we can route the traces to the front side and get everything finalized. You could, at this point as well, you could check what you've done. I know I was doing this when I was designing the main PCB, is I was checking how the layout, the diodes are laid out. And you can kind of just look at how it's done, how it's laid out, and you can see what you like and don't like. So there's that. And in this case, we've got them all laid out. It's all nice. So we're good there. So to route the traces to the front side, we will need to use vias. So I'm going to hit the back copper part here. And I'm going to start routing the traces from the resistors to the LEDs. These are pretty much the last traces you'll need to lay out. So say I want to connect this trace here is wanting to connect to this pad of the LED. You could see that there's that rat's nest line. I'm going to line up this trace. I'm just going to run it sort of right here. That works. I'm going to do a bit of an illegal move as well, but this isn't as bad as before. I'm going to put a via there. Now I put the via on the trace so that I don't need to set the net that it's connected to. And what this does is it creates a tunnel across the, right through the board so that I can access that on the front. So now you can see the via is there on the front when I select the front layer by hitting F.cu there. And when I want to place a trace by clicking that, I can then line up that trace, and just like that, that connection there is made. It is just a small tunnel right on through. You can even see that right here. That is the via. It tunnels right on through, and if I go to the back side, you could see it right there. that just goes on through to that component there. So that is how you kind of bridge the connection between a back layer and a front layer. And as you can see, it is just tunneling right through. Anyway, so we're going to do that for pretty much all of these LEDs. We will need to do vias for, since they are all on the front and all the resistors on in the back. So that's why I'm going to be flipping through these two here quite often to get that. With the vias, sometimes you won't place them on a trace like this. Sometimes you'll want to place them first. So say I want to make this go to this pad here. What I'm going to do is I'm going to place a via right here. Actually, I'll place it right on over here. It won't allow me to connect this trace because I never specified. I never told it, hey, this is the pad I want it to connect to. So what we're going to do is we're going to look at this pad and check the name. It says net-D4-pad2. So that's what we'll do. We'll go here. I'll go to properties. So right click it, hit properties, or alternatively press E. That is how you access properties. And I'm going to set the net to D4-pad2. So I'm going to look for it here. D4-pad2. Boom. I selected the net. If you hit OK, now it'll connect. The rat's nest actually shows that it'll connect. And I can run that across and flip to the front side and then run that across again. Of course, I kind of want it like that. There we go. So just like that. I can adjust this however I want. I'm actually just going to do that. There we go. Yeah, go for it.
The connecting line there,
What do you mean? Oh, the traces? To get the traces, I just hit this side menu.
okay.
It's all on the tools bar, everything that I've been accessing here. Yep. Sometimes you get the footprint. Oh, whoops. Okay. Anyway. So yeah, I'm going to do that for the rest of the LEDs here. And I might not finish all of them since we've got 15 minutes left here. But I'm going to go quickly just to get the point across. So yeah, you guys understand what is poppin'. So just like that. I'm going to place a via. I always place the trace and then the via, simply because it is a pain to have to set the net to every via. Oh yeah, I gotta make sure you're on the front side, and just like that. Yeah, and you can place the traces because sometimes when you look at the PCB, you'll actually see the traces away from everything else. You can place the traces in a bit of a certain way if you want the board to look a bit neat. That's another bit of the artistic side of things. So keep that in mind because you can play around with that all you want. I'm going to place that, and I'm going to go here and backside just like that. Okay, and this can go here. Oh, let's connect to that. Okay. All right, so I'm just gonna do that since it'll take me a while to get all the other LEDs. Assuming I had all the traces done, what I would end up doing is I would start by I'd start by filling in the copper layers, the copper infill. What that does is it allows us to have a large copper plane, just like filling in everything that isn't a trace. It'll just give it a nice copper finish. So if I hit this tool here to add a filled zone, it'll fill it with copper. Now before I do that, I'm going to select my grid size to be 1 millimeter so that snaps a lot coarser. I'm going to grab this and I'm just going to roughly go to the corner, select the net that I want it to be. I'm going to want it to be ground since it'll be a ground plane. And I'm just going to hit OK. Actually, hold on. Before I hit OK, I should also mention, I'll get it after. Anyway, and then I'm just going to draw a square by going from one point to the next. It's like drawing a polygon. And to finalize it, I'll double click on that there, and it'll finish that up. Now, of course, it'll show up as a hatched kind of square with the hatch marks on the edge, or on the edge. If I right click it and go to properties, I can set, I'm going to go down to remove islands. I'm going to have it never remove islands. So what an island is basically a part of the fill that won't be connected to the main ground plane. I put it to never so that it just fills everything that isn't copper in with copper. And when I do that, you can see just like that, we'll have this copper, kind of this copper red plane. So it's not connected to any of the traces that we placed. Just like that, it has that distance of copper to copper distance that we talked about in the properties menu there. It'll keep that distance from the copper no matter what. And yeah, so this is considered a ground plane. To make it a ground plane, I'm just going to throw a via in here. Oh, never mind. Okay. Anyway, if you go to the back side, of course, we don't have a ground plane there. So if you wanted to, you'd throw one in here. Now, I got that error just a second ago because you're meant to do the copper fill after everything. This is like you've done everything and now you're adding in the last piece. So that would be the copper fill for the back. Make sure everything there is good. And then it fills that in. Sometimes you have to go into the properties menu and then exit out of it for it to fill it in. And then there you go. That would be essentially a complete PCB. I should mention that we should have added, if you want to complete this fully, you can add the pinhole for the little badge pin that would go through, and you can throw it in there. And now, if you wanted to, you could update the fill by going to the properties, hitting OK, and it updates it so that now it's not connected to the copper. I think there is also a tool up here to refresh. You could refresh here. Yeah, you could also draw zone fills, and that would also update it, I believe. Yeah, that updates it as well. So that would be how we design that. And then if we hit Alt 3, or if we go to View and 3D Viewer, you can then see the finalized badge right there, just like that. Well, this isn't finalized. It's not even done because of time, but given the time, you'll be able to lay out all the traces however you want and all the components however you want. And yeah, it is not rocket surgery. So to export the files, to order them from a PCB manufacturer, this is the last step to your PCB making journey here. If you go to File and you go to Fabrication Outputs, you can export the Gerber files as well as the drill files. You will want to export both Gerber and drill files. So I'm just going to hit Gerber, and it actually gives me an option for drill. I'm going to hit drill, and I'm going to just generate drill files. The settings are by default the way they should be. Sometimes it'll set the units to inches. Try and be consistent, set it to millimeters or inches depending on what you made your PCB in. So in this case, I'm going to hit millimeters and generate drill file, and it generated them. It'll just say done here. It won't close out of it or anything or tell you anything fancy to show that it's done. It'll just do that, and so you can just hit close on that after it says done. And now you're on the Gerber files. You can select the layers you want to export. In this case, it's already selected the ones that we really need as edge cuts, the solder mask, silk screen, solder paste, and copper. The solder paste would be good. You export that by default just so that they can give you a stencil if you're making a whole bunch of these. Sometimes it's not needed, but we'll keep it in there just because consistency. And when you are done selecting all the settings, you just go in and hit plot, and it will once again tell you done in the output console message here, and you can hit close. Now where that generated those files is right here inside your project folder. You'll see them because they are labeled GBR, GBR job, and DRL. DRL is your drill, GBR is your Gerber, and GBR job is just the job. It just tells the manufacturer, hey, what order do these go in? if you want to use some manufacturers, they will want you to zip them, zip all the files. So I'm just going to create a folder. Actually, I'll create a zipped folder and throw them in there. So compressed zip folder, I'll just call this Blinker PCB. And I can just highlight all of these guys, the Gerber files and the drill files. And I'll just throw them into that zip file. And you don't, once they're zipped up, you don't really need them, so I'm just going to delete them. And so now they're all kind of zipped into this one file here. And I should also mention save. Sometimes KiCad does have an auto save kind of like backup feature, but it won't automatically save every 5 minutes for you like Microsoft might. So do save continuously. Anyway, I'm going to X out of that, and I'm going to grab the zip folder, and I'm going to go and show you how to order. So I'm going to go to PCBWay. Once again, not affiliated, but they've got cheap rates, so it's a good one to start with. That and JLC PCB are also good. And you just go to their website. I normally go to Instant Quote, because what I can do there is I can just quick order the PCB. And you don't need to follow along here because you don't need to order the PCB at all. We've already got a version ordered for you to solder together. But yeah, once you go there, it'll ask you to add a Gerber file, and just like that, we can add our zip file. It specifies here that they accept .rar or .zip files, and you can just select that. And when we do, it'll actually show you the outline of the board. So just like that, it shows us the outline. Although there is something wrong here. I might have messed something up while I was exporting the files here, because the pads are gone. But if everything went well, then you'd see the pads there. And with that, you'll be able to order it, and it even gives you shipping here, $23 US, which is pretty expensive. You could even get them within the day if you wanted to. Bit pricey, but yeah. I believe the original file that we will be using, I'll just show you here if you care. Yeah, these guys here. So this would be the completed board that we're going to be soldering together. Oh, I guess it's not showing the pads. Never mind. So this would be the completed board. For some reason, it's not wanting to show the pads, but that might just be the website. The overlay isn't accurate to what they're actually going to manufacture, but when they do manufacture it, you can order it in whatever you want. Here you could set a whole bunch of settings. I'd keep them the same. Of course, we're going to order this PCB in red, so I could check the red solder mask. And then, yeah, we could have white or black silk screen. An edge connector would be if your board is kind of like a graphics card where it's got the connector right on the edge of the PCB with the gold pads. Surface finish, all that. Yep. So you can just select that. You could also say, hey, do you want an SMD stencil? An SMD stencil is just a metallic, thin metal sheet that you put over the PCB and put solder paste on. So yeah, that is pretty much it for the PCB workshop here. If you have any questions about any parts, I am here until all lengths of the night. I can drive home at any time, so yeah, ask away.